Hello and welcome to Chapter 2, Section 1. This is the setup for fractions. This is our fraction chapter, and we're going to work our way through all of the different parts of the fractions. And once again, you all know something about fractions, but I'm going to explain absolutely everything because I want to fill in any gaps that you have, and guaranteed you all have different gaps. So we're going to cover them all so we can get them all filled in so that you can hit Math 20 running, okay? So we're going to start at the very basics. We've got vocabulary. We're going to start with the numerator and the denominator. The numerator is the number on top. The denominator is the number on the bottom. And while we don't use this word very often, we find common denominators all the time. So this is the word that we throw out all the time. Please remember D is for down if you have a hard time keeping track of the two. When you're making a fraction, you're going to take one item, like this happy little circle here, and you're going to break it into equal parts. How many parts do you break it in? That's your denominator. Here our denominator is 3 because we've broken it into 3 parts. Now, we're only going to use some of those parts. How many of those parts are we going to use? Well, we're going to use 2 of those parts. And that's our numerator. So this is our basic setup for fractions. And I really need you to be able to visualize fractions. This book does a really good job of breaking fractions up into pictures so that you can see what you're doing and you can understand the concept, so that if I say 5/7, you know exactly, you can picture exactly what I mean. So if you go through your book on pages 2.3, 2.4, and 2.5, you're going to find a lot of pictorial representations. I'd like you to do a few of those just to make sure that you know what you're doing. Look at the left-hand column of examples, and then try the guided practice on the right-hand side, and do a few of them to make sure that any question they ask you with those pictures, you know that you can do no problem, okay? Then we get into improper fractions. Now, an improper fraction is a fraction where the numerator, which is the top number, is bigger than the denominator. And while we need to be able to make improper fractions so that we can multiply and divide, when it's an answer, we can't leave them like that. So the first thing we need to be able to do is recognize them, okay? And here I've got some proper fractions. This is what fractions are supposed to look like. So here I've got an example of 3/5, something I've broken into 5 parts, and I'm only talking about 3 of them. Here's 2/7, there's 11/15. There's a lot of fractions out there, okay? And then we have the improper fractions. These are fractions where the top number is either larger than the bottom number or it's the same as the bottom number. We're not allowed to leave fractions like this. Because essentially, what 11/8 means is that I've taken something and I've broken it into 8 pieces, but I'm talking about 11 of them. So I'm obviously talking about more than one thing. So here I've broken this into 8, and I've had to have another thing that I've also broken into 8 so I can get up to my 11 pieces. Now, while you don't have to do this right now, I'm going to give you a little preview. When you're turning your improper fraction into something else, because we can't leave it like this, we're going to turn it into something called a mixed number. And a mixed number is a combination of a whole number and a fraction. You've mixed up your different kinds of numbers. And this, now it's really easy to see in pictorial form. I've got 1 and 3/8 here. But it's not convenient to draw pictures every time we have to change an improper fraction into a mixed number. So we'd like you to also be able to do it mathematically. I'm going to show you how to do it today. Don't worry about mastering it today because we're going to hit it again later on in this chapter. If I've got 11/8, I want to know how many times does 8 go into 11? This is a division problem. How many 8s are there in 11? Well, there's only 1. Now, if I take that 1/8 out of the 11, how many do I have left? Now it's a subtraction problem. What's 11 minus 8? You've taken 8 out. You've only got 3 left. I've got 3 left. 3 what? You're going to put that next. 3/8. And there's my 1 3/8. I don't need a picture to find it anymore. I can do it with math. Fantastic, okay? Now, another improper fraction. I've got 12 over 12. How many times does 12 go into 12? Well, it goes in once. How many are left over? There aren't any. So 12 over 12 is the same as 1. If I drew a picture, I would take my whatever I drew and I'd break it into 12 pieces, and I'd be talking about those 12. So if you look on pages 2-7, 2-8, and 2-9, they give you some examples of the difference between proper fractions and improper fractions. And I'd like you to take some time to go through some of those problems, look at the examples that they show, and then do a couple of the guided practice so that you know that you can answer anything they want you to. But do it until you get comfortable, and that could be 2 or 3 problems, or you could try doing them all. But make sure that you get to a point where you're comfortable. And if they ask you a question and you're not sure how to do it, look next door to that guided, you're in the guided practice. Look next door to that example problem so that they walk you through the steps and see if you can mimic that to the point where you can just do them on your own. Our next job is to compare fractions. Now, when we compare fractions, there are a few different ways that we do this, but we always want to do it with those signs, those sideways triangle signs. So you've got one that means greater than and one that means lesser than. This is greater than, this is lesser than, and then the equal sign. So we're going to be looking at different fractions and comparing them. Now, there are 3 different ways that this book shows you how to do this without actually finding common denominators and working it out mathematically. They want to start you with just kind of understanding the bigger concept here. So the first thing they're going to ask you to do when you're comparing fractions is to draw a picture to see. And they're actually going to ask you to do this. So their example is 2/3 and 3/4. And the question is, what are you going to put in this box? Are you going to put a greater than, a less than, or an equal sign? And I am on 2-10 if you need something to follow along with. So here on the top bar, I'm going to draw a picture of 2/3. So I'm going to take this bar and I'm going to break it into approximately thirds. That's about thirds. And I'm talking about 2 of them. So I'm going to shade this one in. This is 2/3. And then this bar, I am going to break into fourths. I'm going to break it into 4 pieces. So here's about half, and then about half of that, and about half of that. And I'm talking about 3 of them. So I'm going to shade in 3 of these 4 boxes. And if I draw a picture and see, I can see that 3/4 is bigger than 4/3. So I've got this sign, and I've got this sign, and I've got this sign. And I want the big part to go by the big number, and the little part to go by the little number. So I'm going to put this in here, and this says 2/3 is smaller than 3/4. Okay? And on page 210, you have more examples of this. Now, this is all well and good, and you are being asked to do a little bit of that in your homework, but honestly, do I really have to draw pictures? No, you don't. As we go on in this chapter, again, you're gonna find more mathematical ways. The other 2 ways have a little bit more to do with math. So the first one, the next one is comparing the top number, the numerator, when you have the same denominator. So here, I've got a circle that I've drawn, I've divided into fifths. Not equal fifths, because, I'm not good like that, but it's fifths, okay? And I'm asking you to compare which one is bigger, 3/5 or 4/5. Now, I am hoping this one is a little more obvious for you. Because if I break something into fifths, and this guy has 3 pieces of my fifths, and this guy has 4 pieces of my fifths, which one's going to be bigger? Well, this guy, because he's got more of them. They've broken their pieces both into the same size. These pieces are the same size. And this guy has 3 and this guy has 4, which means this guy's bigger. So again, we're going to put 3/5 is smaller than 4/5. Now, what if we wanted to compare denominators with the same numerator? Now, that's a little bit trickier. If the numerator is the same, you have to really understand what's going on with fractions in order to understand which one's bigger and smaller. And really the best way to do this is with fraction bars. So on page 2.9, you have a breakdown of what the different fractions look like. And I'm going to pull you over here to the fraction bar so that I can actually move around to explain to you what that picture means. Essentially what we're saying is we can take one whole and we can break it into 2 pieces, and it's still the same size as the whole, or 3 pieces or 4 pieces, or on and on and on, it doesn't matter. What they want you to see is that when I break something into 2 pieces, these pieces are bigger than if I were to break something into 3 pieces. When I break something into 3 pieces, well, it started out being the same size because our one whole was the same. When I break up, my half, my 1/2 is bigger than my 1/3. When I break something into 3 pieces, the pieces are smaller. So you can see down here, the teal color I broke into 6 pieces. The blue color I broke into 8 pieces. And while they started out being the same size, each individual piece, if I broke into 6 pieces, these are going to be bigger than if I broke them into 8 pieces. So when you're comparing fractions, even though you don't see the size, you know that 1/6 is bigger than 1/8 because something I broke into 6 pieces is going to have bigger chunks than something I had to break into more pieces. So back to these. If I've got 1/4 and 1/5, these pieces are bigger than these pieces, and I've only got one of each, which means this is going to be bigger. So I'm going to put 1/4 is greater than 1/5. Here I've got 3 pieces of each, so this is equal. These are 7ths, these are 8ths. These pieces are cut bigger than these pieces, so these are going to be bigger. So again, 3/7 is greater than 3/8. Do you see? If you'd like to practice these some more, just have a look at them. These are on pages 2-11 and 2-12. Have a look at them, work through them, and make sure you're really comfortable with them.